Okay, so here's the first thing. Let's go over this stuff. On Monday, we talked about linear correlations, linear scatter plots. You guys know what linear looks like. Either positive trending upwards, negative trending downwards. Recap, what does the formula look like for a linear equation? Who remembers? There you go, y equals mx plus b. What does m stand for? The slope, and b is the y-intercept. Algebra 1, freshman year. You guys remember that stuff, right? And obviously, this is what a line looks like. You guys know this stuff. It's you did it in Algebra 1, you did it in Algebra 2. We just recapped it on Monday again, okay? Well, actually, even you know this stuff, right?
Yeah.
All right. If the slope is negative, then m is negative, right? M is negative if the slope is negative. But we're also going to look at exponential functions. Do you remember what an exponential function looks like? What does that mean? Like exponential growth. So a graph grows exponentially. There's a lot of things that grow exponentially. Okay. The population is booming exponentially. The city of Kyle literally is growing exponentially. The year 2000 had less than 5,000 people. The city of Kyle now has over 30,000 people living in it. It is ridiculous. It has grown by 6 times in the past 20 years. And here's the form of the equation for exponential. Does this look familiar? You remember this from last year. This would have been last year, Algebra 2. Now, some of your Algebra 2 teachers may have liked to write it this way. Watch. I don't like writing it this way. A times b to the power of x. Because what do people tend to confuse this multiplication with? A dot or a decimal, right? And I don't like to use that form. So that's why I always use parentheses around the b instead of the dot, because parentheses we know is multiply anyway. This is how you write an equation for a exponential function, and that's what we're going to do today. A is always going to stand for the initial amount. You might have remembered this from last year. And B is the growth factor. It's what do we multiply by each stage of the growth or possible decay. This is what exponential growth looks like. Draven was right about that when he made that sign with his finger. But there's also another exponential function. You know what that one looks like? Close, upside down. It's just starting big and then getting really small. Okay, exponential decay. There's a lot of things that decay exponentially, particularly elements. Okay, elements decay. Have you ever heard of, in chemistry, the half-life of an element? That's how we know how old rocks are, dirt is, dinosaur bones, stuff like that, because of the decay factor of an element inside those materials. Okay, that's my short little lesson right there. But this is what we're gonna do. I'm gonna work on this first page of the homework assignment with you guys. I want you guys to pull this up. If you don't have a printer at home, then you will just do it in your journal. Make sure you clearly number each question so that I can see it when you guys turn this in. You guys here have it already in front of you. Just slow. And here's what I want everybody to do first. Everybody take 30 seconds and please read the directions. If you guys are at home or even here in class, pull this calculator up on your phone. It works really well on the phone. If you want to go to Schoology and open up this assignment, you can click the direct link, or you can just type it into your browser. Okay, those of you guys at home, if you pull up the calculator, it is super. I created this calculator this morning, which is super cool because unlike yesterday, you don't have to clear out any data. The table is already clear. And I have the linear and exponential equations exactly like we're going to use them. So we don't even need anything else there. They're already all in there for us. Okay, so just have that calculator pulled up. I'm on each of these pages. I'm gonna give you a data set, and we're gonna determine whether or not, hey, is a linear equation good for our data? Is an exponential equation good for our data? Which one's the best one? And we're gonna write it in these forms like I just showed you in the slides. And we're gonna round all numbers and equations to the nearest hundredth. So 2 decimal places. 2 decimal places we're gonna round. That's super important because some of these equations won't work well if we don't round 2 decimal places, if we only round to 1. Somebody having connection problems? Or is Nyla just late? All right. You guys ready to do this together? You guys at home ready? You need any more time to get your journal or print this out? More time? Okay.
Why would you put that much in there? It was fine the way it was. I just put it in there just in case you want more salt.
Okay, I'm gonna give you all guys a couple more minutes to print out. So 2 things you should be doing, either printing it out or getting your journal and opening up this calculator right here. Okay, it's under 7.3. With last period, I went over all of page 1 and 2 with you guys if you want to do the same thing. So, but 1 I'm going to do with you, and 2 I want you guys to try to stay a step ahead of me. Okay. Yeah, if you guys want to start, go ahead and do that. Here's what you got. I mean, the directions are right there. Enter the data into the Desmos calculator. Use the magnifying glass feature to zoom into the scatter plot if you need to, and then sketch a scatter plot of the data below. So we're going to take that information right here, and we're going to go to our Desmos calculator and type it in. So if you already are have everything ready, you can go ahead and start doing that. If you think you know what to do next and can keep doing that, and I'll give everybody at home a few minutes to get caught up. Hopefully you've been here either last Thursday or on Monday to do 7.1 and 7.2 with us. That means if you were, then you already know how to use this. If you were not here either one of those days, then you're going to be a little behind and not understand if you haven't done those lessons yet.
How do I get to the calculator?
Open up. Do you have Schoology up? Here, let me put this link in the chat.
Is that linear regression equation inside? I think it's supposed to be right.
Yeah. It's on the assignment, and I just put it in the chat too.
Do you run the R to 2 also? Or?
No, you can write the whole one on there. Yeah, the whole number, because it's only 4 decimal places. Okay. So here's what I was talking about with the magnifying glass on this first one. Since everything is like right there, I don't need to zoom in. But if your scatter plot looks weird, or if this is off to a different spot, right here on the bottom left of the table, a magnifying glass is going to pop up. It's not going to pop up if you already zoomed in the right spot. But if you're not zoomed into the right spot, click this magnifying glass that says zoom fit, and it goes right to the scatter plot. And when I say sketch it, I'm literally mean just do a rough sketch. It does not need to be something perfect. You don't need to label anything. I just want you guys to get in the habit of seeing the pattern. Okay. So when I say rough sketch, that's all you got to do for that rough sketch. Okay. Are you guys at home good for me to keep moving on? Okay. I don't see any objections. So some of you are already moving on, which is great because we did this on Monday. Write the linear regression equation. We need to look. This is the form we're going to write it in, y equals mx plus b. You see it right there. And I already have the line right here. I just got to put the stuff together. So the first thing I'm going to write down, obviously, is y equals. Please always write y equals. It's not truly an equation if you don't write y equals. M is 71.5833, but I'm only going to write it to 2 decimal places. So I'm going to write 71.58. And don't forget to put x in the equation. And then plus b, but b is negative. What do I change? What do I do to a plus sign? Change it to a minus sign. 88.8889. How do I round that one? But 2 decimal places. 88.89 would be the correct rounding.
Isn't that what I said? Oh no.
You said 99. Okay. You guys didn't think I was gonna give you a little test on rounding too, did I? Did you? All right. It doesn't tell us how to round the correlation coefficient, so it's okay to just write out the whole number. It's only 4 decimal places anyway. Which one is it? Is it the r squared or the r? Just the r. So you're just gonna write down the r 0.8895. Let's see. So write that down. Write r equals 0.8895. Not very super strong, but pretty strong, right? 0.889. That's pretty close to 1 based on what we learned on Monday. So pretty strong. Let's take a look at the exponential one. And let's put that one together. The exponential one is also given to you right here. Okay. Y equals a times b to the power of x. They just don't use the parentheses like I do, but I like to use the parentheses like I said. So a is 15.24. So I'm going to write y equals 15.24. I'm going to open parentheses. And b is 1.6061. Which one is it? 1.61. Now here's where a lot of people forget to do. What am I forgetting? The x. And the x on the exponential equation is in the exponents. That's why it's exponential. Okay. So make sure you write the x and it's a x up at the top in the exponents. So this is where we got to use some judgment calls here. Which one is the best function for this? Well, we can judge it a couple of different ways. One, what does it look like just from the scatter plot? Does everybody have this down? Can I clear this out so I can go back to the scatter plot? You guys at home good for me to clear this out? Let me just ask, does anybody need it? Okay, nobody's saying anything, so. One, we can judge it by the curveness of it, and we can think of it that way. Here's another way we can do it. Go to your Desmos and click the little circle to the left of the linear equation. This turns on the line. And look at that. Well, that line just is hitting 2 points. What happens when you click the circle next to the exponential equation? Look at that one. Which one works better, obviously? Lizzie? The exponential is working better. It hits more data points. Right? Put that as your answer right there. Which function works best? Well, the exponential does. It hits more data points. It follows the pattern better. Okay, however you guys want to describe that. So we are going to use the exponential equation to make any type of predictions. Okay, any type of predictions we're going to use in the exponential equation. So question number 6 says, use the regression function you picked, which is going to be exponential, to predict the number of stores in the year 1998 and show your work. Well, first of all, we already know that the years is the x. You might want to label this too. Do this on all the tables. We should have done this at the beginning. The years is x and the number of stores is y from this this coffee shop that's exploding. This might be Starbucks. Who knows? All right. I want to use the exponential equation, but I got to plug in something, and the time is x. The years is x, so I got to plug in for x. But I'm not going to plug in 1998. Why am I not going to plug in 1998? Because x doesn't stand for the actual year number. It stands for the years since 1984. So how many years have passed? You might want to write this down on your paper. I need to figure out how many years have passed. Some of you can do this in your head. How many years have passed? How much?
That's 80. That's 8, right?
1998 to 1994.
Oh, it's 4 years.
4 years?
1998,
1984.
Oh, I asked this out of the 8.
14 years. 14 years have passed. Okay, from 1984 to 1988, 14 years have passed. So 14 is what I'm going to plug into x. But I'm going to use that exponential equation that we came up with in the number 4. So let's write this down and then we'll type it into the calculator. Y equals. You have to remind me. I don't have it written down anymore. What's the equation on number 4? Lizzie? Yeah. 15.24. And instead of to the power of x, we're going to do the power of what? 14. Now, you guys here have a TI-84 calculator that's pretty easy to type in. For you guys at home, if you have an iPhone, hopefully you have that Calculate 84 app that I told you guys about last time, because it's really easy to put it in there. But you can also use the regular cell phone calculator app. I think if you turn it sideways, it brings up the scientific stuff, and you can make an exponent for that. So you can type this into the calculator. It's gonna be a really big number. Type it into the calculator. And let's go ahead and just round that to the nearest whole number, because we're talking about number of stores here. What'd you get, Ethan?
The multiplication, right?
What?
That?
Yeah.
I got 11,982.
982? Dang. It's a lot of stores. And is that a possibility? Maybe. But what did we learn about on Monday? We're making a prediction outside of our data set. So question number 7, is it safe to conclude that this prediction is accurate? Yes or no? It's not safe to do that. we don't know if it's going to continue to explode and grow like that. Not everything continues to grow exponentially. And the reasoning behind it is also, we can say this is an extrapolation. You can write that down. This is an example of extrapolation. No, this is an example of extrapolation. We don't know if data will continue. You don't have to copy this down exactly, but this is the idea right here. Remember, any type of prediction outside of our data is extrapolation, and we just don't know if it's going to continue to be like that. Now, if this is Starbucks, maybe that's probably true. There's a Starbucks on every corner. You ever been to Seattle? There's literally a Starbucks on every single current corner in every single office building. That's where Starbucks started in Seattle. It's crazy. I think they have more Starbucks in the city of Seattle than they do in the entire state of Texas. Something like that. It's ridiculous. How easy was that? Pretty easy? All right. I want you guys to stay ahead of me on this next example. And here's a cool thing. If you go back to your Desmos, watch this. If you just refresh the page, it clears out the table for you. You don't have to go backspace or anything like that. Yeah. So just refresh the page and it'll clear out the table for you. But why don't you guys go ahead and start typing in on page 2. This is a table that shows the relationship between chirps per second of a striped ground cricket and the corresponding ground temperature. Don't ask me why. I found this data on the internet somewhere. Okay. But if you refresh the Desmos page, it will automatically clear everything out. Start typing this data in, and let's start seeing what it looks like. And let's see if we can answer these questions. And I'll, in the next about 5 minutes, I'll start going over some of these answers. So I'm going to give y'all about 5 minutes to start to do this part, put this data into the calculator. Okay. Let me know if you need any help or something's not working or you have any questions. Yeah, are you putting the data in? Okay. Okay, I'm gonna start putting this data in too, so you guys can see if you did it right or not. And it's gonna be like one of those situations where you can't see it, or if it looks all weird, make sure you press the magnifying glass to zoom in, because it'll make it look big like that. And then you can do a little rough sketch. Okay, I'm not gonna sketch it this time, but you guys can definitely sketch it from there. Go ahead and write the two equations down. I'm not going to write them down unless you want me to check your rounding. Let me know if you want me to check your rounding on the way you write down those two equations. And then we'll go over question number 12 in just a minute.
Do we round the exponential also?
Yeah, 2 decimal places. And it's really important that you do 2 decimal places on the exponential one. I'm not going to go into too much detail about why, but definitely the b value needs to be rounded to 2 decimal places. How you guys doing at home? Doing all right? Okay. Can I talk about number 12? Which function works best? It's kind of hard to tell this time, right? Especially if you, what? Yeah. So like if I put the linear one up, it's going through, but you do the one thing I'll point out about the linear is that there's about an equal amount of dots on each side of the line, right? So that's a good thing. The exponential it's still curved, but it does go through the data too. Okay. Here's what I'll tell you. Unless you actually see that kind of curve in the data, I would stick with the linear one. Okay, stick with the linear one. So I would go ahead and write that down for number 12. Linear is probably the best one. And you'll see it in the data sets that I give you. You're going to definitely see that there's a curve in the graph one way or the other. So let's go ahead and use linear for number 12. And then let's use that information to answer number 13, like describe the correlation of the data. Remember the strength, the direction, and the form. The R value is 0.832. So it's strong, but it's not very strong. What's a good adjective we could use this time? Fairly strong? Yeah, that's a good one. So let's do that. Let's use fairly. Number 13. It's a fairly strong. Which direction is it going? No, don't say up though. Positive. Okay. So it's a fairly strong. I'll go ahead and write it down too. Fairly strong, positive, and what form is it? Which one do we pick? Linear correlation. Now, if we picked exponential, then you'll say it's a fairly strong positive exponential correlation. Okay. So, but this time we'd happen to pick linear, so leave it at linear. So let's do number 14 and 15. Let's make a prediction, but you gotta be careful. Okay. Go ahead and tell me, Lizzie, what was the linear equation so that I can have it here? Whoops. 3.41. Plus 22.85. Okay. So use the regression to pick the one that we picked in 12, which is going to be the linear, to predict the temperature when the number of chirps per second is 19.1. Okay. Which variable is the chirps per second, the x or the y? The x. You can look up at the table there. That's the one you put in x. It's the first one. So we're going to plug in 19.1 for x. So I'm going to rewrite my equation. I'm just going to substitute in 19.1 for x. So 3.41 times 19.1 plus 22.85. You don't need to do much other than just type this into the calculator. So use the calculator to figure that out.
So where's that 22.85
from the linear equation? Did you write that one down? You did? Okay, that's where I got it from.
So that's what the x is?
No, the x is the variable. You leave x. Look how I wrote it up here. You leave x as in the equation, and 22.5 was your b.
Oh, I see what you're doing.
Yeah. So all I did was substitute in the 19.1 for x. What'd you get?
87.981.
We'll just do 87.98. You gonna show Ethan how to do that, Draven?
Yeah, I'm putting in this stuff. A point arrows and stuff.
That one was pretty easy, but be careful because the common mistake is everybody's gonna always plug in something for x, and that's not always the case. The last question on this page says use that function to predict the number of chirps when the temperature is 90. And which variable is temperature? Y this time. So I'm going to plug in 90 for y, not x. So I'm going to leave x there. So this is what my setup is going to look like. 90 is equal to 3.41x plus 22.85. What do we do? Yeah, we got to solve for x. So the first step, subtract 22.85 from both sides. That cancels out. We need to figure out, I'm sorry, that doesn't. This cancels out. we need to figure out what 90 minus 22.85 is. $67.15. And I have 3.41x left over here. What's the last step? Yeah, here. By. Good. Divide both sides by 3.41. This cancels out. When I divide that, that leaves me with the x. And x equals what? 21 point what? 39? Yeah. Okay. So I'll just put that right here. You know, in the last problem, I forgot to put the unit. This was temperatures Fahrenheit. You can add that in there too. There's no, I don't think there's any variable for that one. Is that right? 21.39? Yeah, I got something else too.
I got 19.69.
Yeah, that's what I got. Try it again, Lizzie.
Oh, X was the number, that's why. I said divided by 3.1.
19.69. And don't forget to add the degrees for here. 19.69.
I got that one.
All right, so just be careful what you're substituting in for. Got it? How you guys at home doing? Is Desmos working pretty easily for you? I was gonna end up showing you guys how to do this on the calculator, but there's literally like you have to go to one screen to do the scatter plot, one screen to do the linear equation, one screen to do the exponential equation, and then a different screen to just get them to show up on there. So it's way faster that I found this Desmos out for you guys. Use this information to really finish out the rest of this assignment, and it's due on Friday. Those of you guys that are here, and even you guys at home, I'll stay on if you want me to check your work as you're working through it. Okay. Dang, Ethan, you missed a whole page.
Sorry. Read it. Oh. Yeah, hold on. We did one line. Shit. Oh, you can figure it out. I gave you instructions.
Anybody need anything from me? At home, especially?